Hey, good morning or good afternoon. Happy Inertia Day. I'm very excited. That's our shortcuts. All right, you should have all these materials with you and ready to go. I even had it in the waiting room. It was stated while you were waiting for me to open Zoom. Our daily agenda, what is inertia and how will we demonstrate it? Here are our learning objectives for the day. Materials. Oh, look, again, all materials gathered for Inertia Day. Just what I showed you. And you should have a way to record, whether that's your phone, your iPad, or your laptop. Remember, for homework, you should be reviewing 10 to 15 minutes a day. Your summative assessment for the Newton advertisement is due in 2 weeks. If you are in second, third, or fourth period, it is due Monday, November 23rd. Today is the 9th, so 14 days from now. If you are in sixth and seventh period and it is Tuesday, November 10th, again, 14 days from today, 2 weeks. So when you choose how you learn today, you can select a number 1 that you want to work independently. If you would like to work with a partner, please type that partner's name in. Or you can choose number 3 and work with a group with your cameras on. But please remember, no matter how you choose to learn, everybody has to submit their own videos demonstrating each of the activities. All right, Newton's first law of inertia. So if we were to open the Principia, which is the translation of Newton's book about his laws of motion, this is what one of the pages looks like. And the first law actually says, every body preserves in its state of being at rest or of moving uniformly straight forward, except insofar as it is compelled to change its state by forces impressed. What? So that's translated to, an object in motion remains in motion, an object at rest remains at rest, unless acted upon by an unbalanced force. Simple translation of what was already translated from 1600 Latin. So English from the 1600s. So how are we going to demonstrate inertia? Glad you asked. We demonstrate inertia by showing resistance to change in an object's motion. If we have 2 buckets of sand, or maybe this bucket's empty, hard to tell, but which one would be more difficult to push? Obviously the bucket of sand. So this bucket of sand is going to have a greater resistance to movement than this little bucket of sand. Inertia, we can define that as an object's resistance to change of speed and direction. Which vehicle has more inertia and why? We have this little vehicle, we have this large vehicle. Which one would be more, which one would have the greater inertia? Obviously, it would be the car or the vehicle with more mass, because the more mass an object contains, the more resistance the object will have to changing motion. Now, how do we demonstrate these laws of inertia? We can do a simple activity where you take a glass or a cup, maybe put an index card on top of it and a coin, and then you quickly pull the card out of the way. As the card is being pulled towards you, the coin is going to drop into the glass. You're going to watch Steve Spangler do some of these inertia demonstrations. These are similar, but there are some differences to it. Your first submitted activity It's going to be very similar to what Steve Spangler did. I'm demonstrating it and explaining it. And then your second is going to be with a stack. I wish we were in class so I could have you in groups doing this together. But you can use coins. You can, if you have wooden blocks or metal blocks or something, anything that you can stack will work. And there's another video for you. You have an exit ticket. I set it up as a quiz. It's not technically a quiz. It is an exit ticket where I'm asking you some questions about the first law, inertia, and how things went today. And finally, your checklist. Always check in with me before you leave. If you have questions, please do not hesitate to ask.